Hello, and welcome to the Rocks and Rock Cycle installment of the Geology 1 Processes and Products Lab DVD. Today we'll take a very general overlook at rocks and how they fit into the rock cycle. We'll also look at how all rocks are identified when you receive a sample of rocks that you must identify in your lab. Why are we looking at minerals and rocks? Well, remember that the rock cycle is one of our major themes in geology. And if you've already checked out the minerals section on the lab DVD, you know that rocks are made of minerals. There are a few exceptions because, as mentioned in the minerals section, we know that minerals have to have specific characteristics, such as they must be inorganic, they must be solid, they must be crystalline in their form. They don't have to have big crystals, but they do have to be crystalline as far as their molecular or atomic structure. They have to have special characteristics, chemical composition, and specific properties. They have to be solid. Now, not all rocks are made of minerals. There are a couple of notable examples, but in general, when we look at rocks, we look at the mineral composition of the individual rock. What kind of rocks do we have? Well, there are three types of rocks. We have igneous rocks, sedimentary rocks, and metamorphic rocks. Igneous rocks are any type of rock that has formed from molten material. Now, if the molten material and the rock form inside the earth, we say that the igneous rock is intrusive, inside the earth equals intrusive, and that the molten material from which the rock crystallized is magma. Now, once the molten material breaks the surface of the earth or extrudes, we have an extrusive igneous rock, and in that case we can have a volcanic rock. Now, sedimentary rocks are different from igneous rocks. Sedimentary rocks are made of pieces or chemical precipitates from pre-existing rocks. Sedimentary rocks are the most common rock type on the Earth's surface. Finally, we have metamorphic rocks. Metamorphic rocks form from pre-existing rocks that have been changed through heat, pressure, or chemically active fluids. Now, although heat can be added to a rock to change the rock, we can't melt the rock. Why? Well, if we melt the pre-existing rock, we won't have a metamorphic rock. We'll have an igneous rock because igneous rocks form from molten material. Metamorphism can occur to the point right before the rock melts. The pre-existing rock melts. After that, we're looking at an igneous rock. Now, all the rock types are interrelated. Here we have a diagram of the rock cycle. This is one of many, and you can see, get the faithful pointer out, here we go. We see that we have some sediment here that is produced by weathering. There are different types of weathering processes, and those will be discussed in a little bit of detail in the sedimentary rock section of the lab DVD. We have cementation, compaction. The process by which sedimentary rocks are formed is called the lithification process. We can also have sedimentary rocks formed by chemical precipitates. Basically, the water evaporates and leaves behind the minerals in solution. Then, once we have compaction, if we add heat and pressure, we can end up with a metamorphic rock. We change our pre-existing sedimentary rock into a new metamorphic rock. If more heat and pressure are added and we end up melting the rock and forming magma, or on the surface lava, once that magma or lava cools, we end up with an igneous rock. This little diagram shows intrusive igneous rock here below the surface of the earth, as well as an extrusive or volcanic igneous rock forming at the surface of the earth. Now, we say rock cycle, but it doesn't have to go in this pathway. Notice all these lines that crisscross across our diagram. Those are important. It's important to remember that any of these rock types can be transformed into any of the other rock types. You can have a sedimentary rock that undergoes weathering and deposition, cementation, and compaction and form a new sedimentary rock. You can metamorphose a sedimentary rock and get a new type of metamorphic rock. You can melt the sedimentary rock and end up with an igneous rock once that molten material cools. Here is another diagram as well that shows a different view of the rock cycle, but the material is pretty much the same. Notice we can start with molten material, magma, and or lava at the surface, and once that molten material cools, we have an igneous rock. Sedimentary rocks are formed at the surface of the earth because with weathering we end up with pieces or chemicals in solution that are deposited. Compaction, cementation are part of the process of lithification. New sedimentary rocks are formed that way. Then with depth and pressure we end up with heat pressure modifying pre-existing rock types, whether they be sedimentary, metamorphic, or igneous rocks, and forming a new type of rock, a new metamorphic rock. And again, this diagram also shows how we don't have to go through the same pathway to end up with the rocks. It's important to remember that any rock can form any other type of rock and is not limited to one pathway. Okay, so how do we identify rocks? Let's suppose that you receive a rock kit, and instead of having your rocks identified as igneous, sedimentary, or metamorphic, you have a big pile of rocks, such as some of the ones that I have here in front of me. Now, how do you go about classifying some of these rocks? All rocks, whether they are igneous, metamorphic, and sedimentary, are classified based on two properties. Those are texture and composition. The texture of the rock describes the size, the shape, and the arrangement of the grains, crystals, or pieces within the rock. The composition tells us what minerals or what molecules, what type of material is present. When you look at the texture, you can basically have three choices for texture. There is a crystalline texture, and crystalline texture is very common in igneous rocks. It describes crystals making up the individual rock. Also, you can have a crystalline sedimentary rock because as the water evaporates and minerals are left behind from the solution, you can form crystals such as halite, also gypsum. Now, metamorphic rocks can have some crystalline structure as well, and we'll look at that in the metamorphic section of the lab DVD. So, other than crystalline, you can also have a fragmental or clastic texture. This describes those rocks that are pieced together from pre-existing rock types. It looks like we have rock pieces that are cemented together. This is characteristic of sedimentary rocks, although we can see some volcanic rocks that are formed from pyroclastic material that's cemented together. And finally, we have a glassy or hyaline texture. This is a texture that describes a non-orderly arrangement of the minerals within the rock. In other words, we have a glass. It's amorphous. The minerals did not have time to arrange themselves in a nice crystalline fashion. So, when you describe the texture of a rock, you can stick with a crystalline texture, and we'll look at some terms that describe that in the different rock types that we'll discuss in the lab DVD. And you can have a clastic detrital rock. That describes a sedimentary rock texture most often. Or you can have a hyaline texture or a glassy texture to a rock. And finally, sometimes your texture does not give you enough clues as to what type of rock you have. You have to further describe it chemically or the chemical composition. All rocks are classified based on texture and composition. Okay, let's look at some of the rocks that I have here. And we will look at some of the common textures in these rocks in just a minute. But let's see. I have some fairly large size specimens. I hope I can get them in. Overhead. We go. Aha. That was not going to fit in very well. Okay, here we go. Let's say you just got, I'll stick this guy over here so he doesn't fade out against the black table. Okay, here are some rocks, a collection of rocks. And let's say it is your job to figure out whether they are igneous, sedimentary, or metamorphic. Well, where do you begin? Well, first off, I guess the easiest way to start, Sedimentary rocks are made of pieces of pre-existing rock types. They're detrital, or they can be precipitates, but the detrital ones are really easy to pick out. So, let's look at this guy. It's fairly obvious that there are individual rock pieces that have been cemented together. This is a nice flat surface that's been cut with a rock saw. You would encounter the rock more like this. When you cut it, it's easy to see the individual clasts or pieces of the rock. So this is a sedimentary rock. Got one down. Okay. Now, this one can be a little confusing. How do you tell whether or not you have crystals or whether or not you have pieces? In this case, you may be thinking, well, that looks like a crystalline rock, maybe an igneous rock, because I see some nice big crystals there. And it's actually a sedimentary rock. If you look closely at the edges here, you can actually see breaking and weathering of some of these rock pieces. It's very angular, but there is some weathering along some of these pieces, some of these clasts. This, again, is a sedimentary rock. Okay. Now, what about something like this? Now, we've seen things like this before in mineral sections. This is a precipitated rock. These types of rocks form when water evaporates and leaves behind the minerals, which were dissolved in the water. So, as these minerals are left behind and they accumulate over a lot of time, we end up with, again, a sedimentary rock. But in this case, we're not looking at a clastic sedimentary rock, or a detrital is another term. We have pieces here, and in this case we have crystals. Both are sedimentary rocks. However, one is detrital and one is crystalline. Okay, so what do we have left here? What about this guy? How would we classify a rock like this? Let's go ahead and move him over to the side so you can get a little bit closer view. Now, when you look at this rock, you should be able to pick out some mineral crystals. We see some dark minerals. We see some pink feldspar. We see some gray, which is quartz. But basically, this is a rock that is composed of different minerals, different crystalline minerals. Let's compare that. I'll just put on the side this guy. What's the difference between these two rocks? Well, this rock is made of crystals that cooled out of a magma, and this rock is made of pieces of pre-existing rock that were weathered and subsequently cemented together. This is the sedimentary rock. This is an igneous rock. Okay, what about this one? I'm going to bring over to the side too. It's got a very shiny surface. And this also has been cut and polished. Different rocks are used quite commonly now as building materials, and this is one of them. Your builder may call this granite, but it's not. It's actually an igneous rock called gabbro. Well, how did I know it was an igneous rock? It's not made of pieces of a rock that are cemented together. Instead, you can see individual crystals in a rock. And these crystals are very large. The large silver shiny ones are feldspar, plagioclase feldspar. And these crystals had time to cool. In the igneous rock section, we'll talk a little bit more about how igneous rocks are formed, and those that are formed inside the earth have more time in which their minerals can form into larger crystals. So this is an igneous rock. Again, compare to this guy. We see crystals, and I can turn this one to the side, you can even see the crystals this way, versus this, where we have pieces of a rock. Sedimentary, igneous. Okay, now what about this one? Move him over here. This one looks like it has crystals. It's shiny. It reflects light really well. But there's a difference between this rock, and let's go back to this rock. Can you spot it? Let's bring him over here. Okay. Now, this is an igneous rock. We've established that because it has crystals, interlocking crystals that have cooled formed from the cooling of magma. They're bigger crystals, so they formed inside the Earth. On this case, we have something a little different. Look at our crystals. Can you see that they kind of line up? Look at this line of darker minerals running through the rock. This is a metamorphic rock. Under heat and pressure, metamorphic rocks exhibit a special type of texture called foliation. Foliation occurs when the platy minerals line up, flatten out. So here we see a metamorphic rock because we see aligned minerals. Different from an igneous rock where we just have crystals interspersed. No regular pattern, okay? Igneous, and this one would be metamorphic. Again, look at that nice foliation, line of minerals. So that's how we can tell metamorphic rocks from igneous rocks. Do we always see this nice foliation? No, unfortunately not. Let's look again. Here we have a couple of other rocks. Now this one's fairly obvious, and I'll bring that over here. I think anyone who's been shopping at one of the garden centers knows that this type of rock is available to landscape your yard. This is commonly called lava rock. It's scoria, and you can see different bubbles from the escaping gases. This forms as the rock cools, the gases escape and leave behind the holes. This is a volcanic rock, and of course volcanic rocks are igneous rocks. Let's go back here. How many do we have left now? We have 1, 2, 3, 4, 5. How about the nice green one? This guy, under close examination, let's bring him here. Actually, he's kind of even breaking apart into pretty fine sand-sized grains. And there's another clue here as well. See some little white things in here. Let me turn it this way. This side has been cut. You can actually see cross-sections of shells. So this rock looks like it's made of pieces. That gives us a clue that it's a sedimentary rock. And we also see some little fossils included. Fossils are most commonly found in sedimentary rock. There are a couple of exceptions, but they are very rare. However, sedimentary rocks can be chock full of fossils. So this would be a sedimentary rock. It is a detrital sedimentary rock. It's made of pieces. It does have fossils in it. Okay. Here we have another rock that looks like it is made of crystals. And here's the cut and polish side. And you can see, especially on the cut and polish side, we have some pink feldspar crystals, we have some white feldspar crystals, we have some quartz crystals in there, and we have some darker minerals. I think that's biotite. This would be an igneous rock. We have interlocking crystals. Now, we also talked about crystals for sedimentary rock. Remember this guy. Notice how we don't have different minerals forming the rock. Basically, we have one mineral that's precipitated out of solution as the water evaporates. In this case, we have interlocking crystals, igneous, sedimentary. This is formed inside the earth because, again, the crystals are rather large. More crystals. Let's bring this back over here. This little guy is a small sample, and these little red spots actually are a mineral called garnet, January's birthstone. And if you look carefully, you see something that kind of reminds us back of this rock over here. Remember the minerals lining up, that special texture called foliation? Well, it's also present in this rock. Can you see how some of the dark minerals line up? And here we have light minerals lining up. Let me get the pointer, that may help a little bit. Okay, see the light minerals lining up and moving down, and here we have dark minerals lining up across the top. When you see foliation, when the minerals are aligned in a parallel fashion, you have a metamorphic rock. Another example, metamorphic rock. Okay, we have two left. And this one, I think you could probably pick out fairly easily. Note that when we talk about limestone, it's a sedimentary rock. Limestone can be precipitated inorganically without organisms involved, or it can also be made of the shells of organisms. It wouldn't be a mineral in that case, but it's still a rock. When we metamorphose limestone, we get something called marble, and marble can come in lots of different colors. Let's bring it over here and I'll show you why I know it's marble. Let's see, there we go. Can you see the crystals? Nice sized crystals in this rock. It has been subjected to heat and pressure, and although it does not show that special foliation that other metamorphic rocks do, it has been metamorphosed. Now, how do we know it's still limestone? Well, calcite and limestone will effervesce in the presence of HCl. Can you see how adding a dilute solution will also cause effervescence from marble? Marble is commonly used as a building material too, but it's very porous. It's not such a good idea, and it's soft. It's not such a good idea in your kitchen. It will scratch up fairly easily. Okay, last rock, and this is a big rock. This is actually part of my fireplace. Not the part that was already installed, mind you, but a leftover piece. Notice that we see some shiny minerals, and these are actually micas. Micas are very indicative of a metamorphic rock. But also, if we look at the side of the rock, although we don't necessarily see a foliation here, not a big foliation, we do see these nice planes upon which the rock will split. This is a schist, and this also is a metamorphic rock. There is some alignment of the minerals, but probably the best way to see that is through a hand lens. If you have a hand lens, feel free to use it regularly. It does help us identify some of these rock types. Okay, so let's just summarize some of the textures. When we're looking at rocks and we need to identify igneous, sedimentary, or metamorphic rocks, it's sometimes handy to go back and look at the possibilities that exist in the textures. And on the PowerPoint slide, you will see up at the top we have some common igneous textures here. We didn't show this, but this is a glassy texture. This is formed when the lava cools so quickly it doesn't have time to form even small crystals. We saw this guy. This has a vesicular texture. It's also a glassy texture, and that's formed by escaping gases. We have small crystals and we have large crystals in igneous rocks. Now, down here, common metamorphic rocks, this is an equigranular texture. We see this with some marbles, crystals of equal size. This is banding, foliation, very large layers where the dark and light minerals will line up. We can also have some crystalline textures that aren't foliated. In this case, we do have a foliation. This, I think, is a schist. From the picture, it's kind of hard to tell. But it's not a foliation that is so obvious as this guy. This one is very obvious and banded. And here's another crystalline texture. Again, this one is also foliated. And I know these pictures are kind of small. When you have the hand samples, you're usually able to tell by the slaty cleavage or the schist that the minerals are actually lined up. Foliation. With marble, however, you're not. You have to look for the crystals. More pressure, we get equigranular crystal growth. Now, in the bottom row, we see some sedimentary rocks. The fossil here is a big tip-off. This has to be a sedimentary rock. The next photo over shows some sand-sized grains. We can also have some bigger pieces, for example, some gravels that are cemented together. But keep in mind that some sedimentary rocks are formed when minerals precipitate out of solution. That's how the salt that's deposited along the Gulf Coast was formed. As the Gulf of Mexico was forming, the water was separated. The Gulf did not have free connection to what eventually became the Atlantic Ocean, so seawater would spill over, evaporate, and leave behind the salt. The halite that is mined today at several spots along the Gulf Coast. Now imagine the amount of seawater. Seawater only is about 4% of volume as far as salt. Imagine the amount of seawater that had to spill over into the Gulf of Mexico and evaporate to leave behind 1,000 meters of salt that are deposited in the Gulf of Mexico. Okay, well, I hope this helps you to see that it's not always so difficult to separate the rocks, igneous, metamorphic, and sedimentary, into the rock types. However, there will be some occasionally that can kind of confuse you. Don't worry, we get confused too. Usually context is everything. When you find a rock out in the field, it really helps when you know what the setting is, what the depositional environment is, whether or not you are in an area where igneous rocks are exposed, or whether or not you're in an arid area where you might find a lot of evaporites or sedimentary rocks that have been precipitated from solution. As always, if you have any questions, please feel free to email your instructor. He or she is always willing to help. Thanks for joining me, and have a good day.